This video will cover a couple different kinds of word problems that were not on the other 6.6 rational equation word problems. So this says one worker can rake the leaves in 3 hours, and working with a second worker, the two workers can rake the leaves in 2 hours. How long would it take the second worker to rake all the leaves by himself? Well, as soon as you see that we're talking about work, then you should realize that we are looking at this kind of setup. We're going to set up two fractions like we did on the previous problem. Together over alone plus together over alone equals 1. This is the setup you can use on any of the work problems. The work problems we did in the previous video always gave you the two alone times, and we were trying to figure out the together time. This one's a little different. This says one worker can rake the leaves in 3 hours. So this is this guy's alone time. 3 hours is his denominator. And working with a second worker, that's the together part, the two workers can rake the leaves in 2 hours. So the numerator of both fractions is 2. What we're looking for is how long it would take the second worker, that's this guy, to rake all the leaves by himself. This is where the x goes. We don't know his alone time. This is a rational equation which we should know how to solve. It has a denominator we want to get rid of, so we're going to multiply both sides by the common denominator, which is 3x. So I'm going to fill in 3x on both sides. Over here, I'm going to have a little bit of canceling. The 3's cancel, and I have 2 times x is 2x. Plus, for this part, I have to do 3x times this also. The x's cancel, and I have 2 times 3, which is 6. Don't forget to do the other side. 3x times 1 is 3x. What we have here is a very simple equation to solve because the fractions are gone. All I have to do is subtract 2x from both sides, and I get 6 equals x, or x equals 6 hours. So 6 hours is how long it would take this guy to rake the leaves all by himself. And you can check this by putting 6 in here for x. We're looking at 2/3 plus 2 over 6. Does that equal 1? You can type that in your calculator to check it, or we can do it by hand with the fact that 2 over 6 reduces to the fraction 1/3, and clearly 2/3 plus 1/3 does equal 1. So the 6 hours does check. Now this number 5 refers to the fact that this is on the new worksheet. This next one is a very similar problem. It's not on the worksheet, but it's just to give us another little bit of practice on this. So as soon as you see it, this being a work situation, now it doesn't use the word work, but filling a pool is work. So we know we're going to use this setup, the together over alone plus together over alone equals 1. Always equal to 1 because the 1 stands for the total job. So the two hoses can fill a pool in 6 hours. That is how long these two hoses are working together. So that's the same numerator for both fractions. One hose needs 10 hours. That's this denominator. What we're looking for, like on the last problem, is the denominator for this fraction right there. Just like the last one, we're going to multiply both sides by the common denominator, which is 10x. And incidentally, when I'm multiplying both sides by 10x, it really means I have to multiply that fraction by 10x and that fraction by 10x. And if I have chosen the common denominator correctly, these existing denominators should cancel out, and they do. 10 cancels with that 10, leaving x. So x times 6 is 6x. And over here, x cancels with x, and I have to do 10 times 6, which is 60. And then over here, I have to do 10x times 1, which is just 10x. Very simple equation to solve. Subtract 6x from both sides will give me 4x. Divide both sides by 4, and x equals 15 hours. And you can put the 15 in here and check it like I did on the last one. So that's a couple of the more complicated work problems. The next two on this video go back to our distance equals rate times time. Anytime you look at a problem and you're talking about distance, you're talking about miles per hour, which is rate, that says we need to use distance equals rate times time. Now, when you're going to do a distance equals rate times time problem, I suggest you set it up in a chart format like this, where we have r times t equals d. The other thing is we need to label what's going on over here. Well, this plane is flying 420 miles with the wind and 350 miles against the wind. So my labels are just going to be with and against. So now go through the problem and pick out these numbers that you can put into the chart. A plane flies 420 miles with the wind. That's distance because it's miles. So I'm putting 420 in my chart right here. And 350 miles against the wind. That's distance against. So those are very easy to put in the chart. This might be a little complicated to you right now. It says it flies 420 miles in the same amount of time. Well, we can't really fill in the time with that phrase. We need to do a little bit more work before we get there. So let's go back to this. The speed of the wind is 15 miles per hour. Find the speed of the plane in still air. You know that if you are flying or sailing or biking with the wind, your rate is the plane plus the wind, because the wind is helping. When you turn around and go against the wind, it's the plane minus the wind. So let's fill this in a little better. We know the wind is 15 miles an hour. So this plane with the wind is the plane, P, plus the wind, which is 15. So in the red, that is my expression for the rate of the plane with the wind. Very similar setup here. This is going to be P minus 15. Now, D equals R times T. Think back to formula kind of things that you've done. And we've looked at these before also. I need to fill something into my chart for T. And I'm going to use this fact. If D equals R times T, I need an expression for T. So let's do something to get this T alone. So let's divide both sides by R. So D over R is the same thing as T. That's important because that's how I'm going to fill in my chart here for T. Since T is D over R, I'm just going to put this D, which is 420, over this R, which is P plus 15. And I'm going to do the exact same thing right here. This is 350, which is the D, over its R, which is P minus 15. Now, how does that help? Well, this is where we go back to the problem. It says it flies 420 miles with the wind and 350 miles against the wind in the same length of time. Same means equal. So finally, I'm going to have an equation, and my equation is 420 over P plus 15 equals 350 over P minus 15. This is a proportion. All we have to do is cross multiply and solve. By this, I'm going to slide over here where I'm going to have a little more room, and this will be 420p minus 6,300 equals, cross multiply here, 350p plus 5250. And this is just our basic equation. We want to get our letters over here and our numbers over there. So subtract 350p from both sides will give us 70p. Add 6,300 over here, and I get 11,550. Divide both sides by 70, and P equals 165 miles per hour. That is the speed of the plane in still air. And what still air means, there's no wind at all. So we're going to do another one just like this, just with kind of different numbers. So let's take a look up here. Same idea, same kind of chart. Let's fill in with what we have. The plane flies 405 miles with the wind, so that's my distance going here, and 315 miles against the wind. Like the last problem, with the wind means it's the plane plus the wind, which specifically is P plus 20, and against the wind is P minus the wind, which for us is P minus 20. Since the problem states that these two distances are covered in the same length of time, we are going to set these two times equal to each other. To get the entries in the chart, we just have to put the distance divided by the rate like we did on the last problem. So this is 405 over P plus 20 and 315 over P minus 20. These two entries are equal, which gives us our equation. 405 over P plus 20 equal to 315 over P minus 20. This is a proportion. All we have to do is cross multiply and solve. So cross multiply here. 405 times P is 405P. 405 times 20 is 8100 equals, cross multiply here, 315 times p is 315p, plus 315 times 20 is 6,300. So we have our standard equation. We just need to solve this by getting the p's on one side and the numbers on the other. So subtract 315p from both sides gives you 90p. Add 8,100 to both sides gives you 14,400. Divide both sides by 90. And this will give us our p, which is the speed of the plane in still air, of 160 miles per hour.